Okay, let's take a peek at this question. So we've got high school science teacher of 78 students, so it's always good to circle numbers. Of those students, 35 are in band and 32 are in sports. So right away that can tell us we're organizing our students into band and sports. But 32 plus 35 is 67 students potentially accounted for. And then it says we have another, which is not 78 yet. So this next sentence makes sense. There's 16 students who are not in band or on a sports team. So they're not in band and they don't do sports. So there's 16 of those. One student from the 78 will be selected at random. So let the probability of event B be that they're in band, and the event S is defining that they're in sports. So are B and S mutually exclusive? So first thing we want to think about is, what does mutually exclusive mean? So that means the two things cannot happen at the same time. So for this case, we want to think about, can I be in band and can I be in sports at the same time? I mean, probably. We just need to maybe organize our data with our numbers to see if we have an overlap in those two. Generally, you should be able to do both. There are band kids and sports kids. But what we want to try to find out is how to numerically prove this. So if two events are mutually exclusive, they're not going to happen at the same time. So being in band and being in sports would have a probability of 0. Like, it wouldn't happen if they're mutually exclusive. So right away, knowing the definition of mutually exclusive and seeing that these two options say, sure, they're mutually exclusive, but then having a probability number associated with that doesn't make sense. If it's mutually exclusive, the chance of them happening together is 0 because they don't happen together. So right away, we can cross these two out. Now, what this tells us, we want to look at our notation. B and the little U thing is B and S. So if I think about a Venn diagram, the B and S part is my overlap. So I need to see what my overlap is going to be in this particular situation. So I'll put my band students over here and my sports students over here. And I know already that 16 students don't fit into either category. So I can put them on the outside, and then I just have 3 other regions to fill in. So we know that there are 35 band students. So these two sections have to be 35. The band circle has to represent 35 kids, and the sports circle has to represent 32 kids. So let's take a look at some of our data. I know if I just add up band and sports, I'm going to get 67 kids total. But let's check something out. I already know 16 of them are out here. So if I take 67 plus 16, that's probably not going to get me 78. No, that's going to be 83 accounted for. So that means I've double counted, right? Because the overlap is basically is it happening in the 35 and it's happening in the 32. So if I just take all my numbers and add them up, so the 35, the 32, and the 16, that's going to give me 83 kids, but I only have 78 kids. So what that means, there's a difference of 5 there. That difference of 5 is going to be my overlap. So because I've counted it twice. If I count the 35 and I count the 32, that means I've counted the 5 2 times. And that's why I see 83 people represented instead of 78. So my overlap is 5, which means there's 30 people here, which I don't really need, but just for the fun of it, we can fill it in. 27 people there. If I add all those 4 numbers together, I should get 78. So in that case, that means 5 people have to be in both camps. That means that you have a 5 out of 78 chance of picking somebody that does sports and is in band. So these are not mutually exclusive. There's 5 people here. So A is going to be the best option because it shows us the probability of getting that overlap, 5 out of 78.